Imagine a young apprentice chef in a busy kitchen who never reads a single printed recipe. Instead, she tastes, tweaks, and remembers what works. Over time, she starts guessing the right balance of salt, sweetness, and heat, even for dishes she's never made before. Okay, picture this. You're visiting a neighborhood bistro, and the chef behind the pass is this apprentice. On the first day, she follows a recipe card. By the 10th day, she's already adjusting amounts by instinct. By the 100th, she can whip up a new dish that fits a customer's diet and mood. That little story is exactly how machine learning works. So let's spend the next few minutes following her, step by step. In our kitchen, the printed recipes are like old-fashioned computer programs. They tell you exactly what to do. Add a cup of flour, stir for 2 minutes, bake at 350. They work great when the situation matches the instructions exactly. But life rarely matches a recipe card. Customers ask for less salt, someone's allergic to nuts, the tomatoes are a little sweeter than usual. The apprentice chef doesn't treat the recipe as gospel. She tastes, she remembers, and she adjusts. She learns from examples and from feedback. Now let's match the kitchen to the machine learning world. The apprentice is the learning system. The ingredients, previous dishes, and customer reactions are the data. Tasting, experimenting, and tweaking is called training. The little internal idea she forms of how much salt to add is like a model, a compact set of rules she uses to make decisions. When she uses that idea to season a new plate, that's a prediction. And when a diner says, perfect or too sour, that feedback helps her get better. So what is learning here? Plainly, it's improving decisions based on experience. No magic. In the kitchen, learning happens when the apprentice tries a dish, notices it's bland, adds more salt next time, and the diner smiles. In machine learning, a system tweaks its internal settings so it makes better choices when it sees similar situations again. Let's slow down and define a few terms in everyday language, keeping our chef close by. Data. These are the ingredients and past meals, facts about what happened before. For the chef, data might be how many people liked yesterday's soup, how spicy the peppers were, and a photo of that oddly shaped apple. For a machine, data might be images, numbers, or words collected from the world. Model. This is the apprentice's mental recipe, not a printed card, but a learned sense of how much of something to use. It's a simple rulebook she forms from experience. In machines, the model is a program made of numbers that decide what to do with new inputs. Training. Practice sessions where the chef tries things and pays attention to the result. For machines, training means showing lots of examples and letting the model adjust itself to reduce mistakes. Prediction. When the chef tastes broth and decides to add a pinch of salt, that choice is a prediction. She's predicting what will make the diner happy. Machines predict labels, prices, or actions based on what they learned. Feedback. The diner's reaction, a smile, a complaint, or a tip, tells the chef whether the choice was good. In machine learning, feedback is the correct answer, or a reward signal that guides improvement. Generalization. This is the chef's ability to apply what she learned about one tomato soup to a different vegetable stew. It's the most important skill. If she only memorized one exact recipe and fails when anything changes, she didn't really learn. A few quick clarifying points. Training usually needs many examples. The chef wouldn't learn to cook all day from one perfect soup. Also, we don't mean the chef is replacing recipes forever. Recipes are useful starting points. Machine learning is most helpful when rules are hard to write down but easy to learn from examples. Let's make this concrete with everyday tech you already know, but framed in our kitchen language. First example, your phone's keyboard that guesses the next word. Imagine the apprentice chef has noticed that when a customer orders spicy, they often follow with no dairy. She starts predicting that preference. The keyboard watches how you type and learns patterns. You type, "I'll be there in," and it suggests 10 minutes. The keyboard's model is like the chef's learned habit. It used past messages, data, and your corrections, feedback, to make better guesses. Second example, a photo app that groups pictures of friends together. Think of the chef recognizing customers by their favorite table or preferred dishes. Over time, she learns that the couple near the window always orders the tart. So when she sees someone at that table, she knows what they'll like. Modern photo apps do this by looking at many photos, learning what faces look like, and predicting which images belong to the same person. They weren't given a printed rule that says, "This is Bob." They learned from examples, just like the apprentice learns faces and preferences. Another everyday example is a streaming service recommending shows. Imagine the chef has noticed that customers who liked the smoky stew often enjoy a lemony dessert. She learns cross-preferences and suggests a dish that matches a diner's previous choices. That's a recommendation model in action. It notices patterns across users and makes predictions about what someone will enjoy next. One concern people have is, what if the apprentice learns the wrong thing? In our kitchen, that looks like a chef who keeps adding sugar because one diner liked it once. In machine learning, that's called overfitting, when a model memorizes the examples it saw instead of learning the general rule. The cure is more varied practice and careful checks. The chef needs to taste and serve many different customers and get honest feedback to avoid strange habits. Another worry, can the apprentice explain why she added something? Sometimes she can. The tomatoes were sour, but sometimes it's just a gut feel. Similarly, some machine learning models are very transparent, simple rules you can read, and others are more like intuition. They work, but don't explain themselves clearly. That's okay for many uses, but for important decisions, we prefer models that can explain their choices. If you step back, you'll notice machine learning is everywhere, because lots of everyday problems are like cooking without perfect recipes. Many small choices, lots of noisy information, and a need to adapt. We use it to sort emails, show relevant ads, detect broken parts in factories, or help doctors find patterns in scans. In every case, we're doing the same basic thing, using past examples and feedback to make better future choices. Before we wrap up, let's return to our apprentice one last time. She started by following a printed recipe. Then she tasted and adjusted. She kept notes, tried variations, watched customer reactions, and over time, she developed a reliable, flexible sense of taste, a model that generalizes. She didn't replace recipes with guesswork. She combined instructions, practice, and feedback. That blend of guided practice and adaptation is exactly what machine learning does. So, the next time someone says machine learning, picture that apprentice chef in a warm kitchen. Not mysterious, not magical, but curious, experimental, and gradually better because of practice and feedback. It's less about perfect rules and more about getting better with experience. Thanks for spending time with this kitchen story. If you want more friendly, story-driven explainers about AI and cloud, this channel makes them simple and useful. If you liked this story, hit like and subscribe for more friendly explainers about AI and cloud. See you next time.